finding the exercises a bit hard. We have 57 saying the bug buster exercises were hard, and then 43 with the exercises were great. So
okay,
some challenge there.
That's going to be interesting. Yeah, last week's exercise or Monday's exercises, I do have to agree. We did step them up a little bit of a notch there when it's starting to add in loops and stuff like that, and using lists. There's a whole bunch of different layers of complexity. The key point is if you can go and try to keep track of what you can do for just one single piece of it, and then you start duplicating that code across multiple pieces there. Those are the two ways I like to problem solve, having to deal with anything that involves a list and a loop. Today's topic is going to be quite different from those, though. We're going to be talking about something called functions, and in my opinion, they are excellent things that are super incredible to use, but they're also one of the harder ones to wrap your head around, just because they seem to be something that's kind of abstract, and admittedly, for beginner levels, a lot of people kind of think they're useless, but as soon as you move from baby steps of programming into some of our general regular programming, they become so useful and they show up everywhere. Before I do that, though, let me quickly talk about another cool application for software out there. There's a tool called DeepBar out there that really shakes up what your understanding of programming is. So you guys might understand programming is something that has to do with computers, right? Computers, databases, you know, smartphones, games, etc. So what does chemistry have to do with computation? The answer is that computers are excellent at doing things that we cannot comprehend in the slightest. Like, for example, trying to predict how proteins going to fold. For anybody who knows a touch of biology, proteins are just ginormous molecules that are stored within our human bodies. And then the way they interact with themselves, they collapse into this crazy wound up shape. And I don't know very much about this topic myself, but I just know it's incredibly complicated. And the easiest way how to go and do this is trying to predict it by hand. But the more effective way now is to be using machine learning models here. Yes, AI to go and make these predictions for us so that we can handle the hundreds of thousands or maybe even millions of possible interactions and possible combinations and give a computer that challenge rather than us. So programming, so incredibly useful for so many applications outside of directly typing code on the computer and working with computer related software. Anyway, enough about that little tangent here. Let me just quickly give a quick review over the 4 in range kind of concept I was talking about earlier. Last time I was talking about saying if we wanted to go and loop over 2 lists at the same time here. So on my screen, I have an example of locations and sizes. And I want to go and draw a circle that lines up with this location with location 40, size 12, location 100, size 33, etc. How do I get those to pair up together? I use something called range. That's a really convenient way. Range goes up by the counting numbers here, and it tells you the number of items in the list, but it does not tell you what the last number is. In fact, it tells you the number right before. So range of 5 goes 0, 1, 2, 3, 4, stops there. Total of 5 numbers there, but it starts at 0, ends at right before that. And that's a really useful way, if you remember, that it just gives you a list of numbers. You can print out a number 5 times using this method here, or in this other example, we see you have a length of 4 in this list, 1, 2, 3, 4, you just count them up on your fingers. So you say a range of 4. And because lists use that natural indexing style starting at 0, just like how this range does, we could say that location I of the 0th element is going to be that 40. And then the size of I is going to be that 12. And we can work our way up that list. Luckily, we don't need to rely on that too much for today, but it's good to keep that in the back of your mind. So I also want to go and quickly touch about another way how to go and get mouse inputs. You guys are all familiar with mouse pressed as a way how to go and check whether or not your mouse is being held down at the moment. But there's also another very, very similar idea on how do you go and detect once if there's only a singular click here. And we use this thing called mouse pressed round brackets on that. And let's go and take a quick look at that. Oh, shoot, I keep pressing the wrong button. Let's go take a quick look at how that's going to look here. So I'm going to do my usual from processing, import, star, def, setup, round bracket, colon, size 500, 500. And I'm going to do my def draw, round bracket, colon, background. Let's just go with black for today. And then instead of putting my code in the regular draw, as you see here, instead of having those two indents, I'm going to go line it all the way to the far left side here. And then I'm going to go def mouse pressed. Round bracket, colon. And this is a type of code that should only execute once whenever I click my mouse. So print clicked. And let's go and check out whether or not I got this right on my first try. Oops, last part, as usual, at the very, very bottom here, we type in run. And with that, let's go and check out. Clicked, and I'm clicking and holding my mouse right now. You cannot see me, but I'm really holding down it and pressing it down. And it's only showing the clicked once per click there. So every single time I click it, it runs this code only once. That's a little bit more useful than the other version where you click and hold the mouse down and it only stays down. Well, actually, which one you prefer to use really depends on the situation. You now have another tool in your toolbox. But luckily for me, I don't think that we need to have that memorized either. It's just kind of useful to know. But the reason I wanted to go and show you guys this here is that it's really radically different than all the other things we've been teaching so far, because it uses that def word again, which is short for the word define. And in fact, it really does segue into today's conversation, because this link here is a function. We just written up another example of a function. It looks pretty darn familiar because we already have two other functions written up on here. We have def setup as our first function and def draw as a second function here. And these ones are rather unique because we're setting up the contents within that, but with very specialized names. Oops, here we go. Mouse press, I give you another example on how to go and use that code here. So you can use mouse press, and then you could draw a circle right exactly where you click, or if you're lazy like me, you just only print. And this code only just runs once per click, which is pretty darn useful. Anyway, functions, back to what I was talking about here. Functions, in short, are a way how to go and organize your code into a really big collection of things. So when I was talking about def setup and def draw, you remember that with def draw, I normally punch in 30 lines of code or so. All that stuff belongs to the function called draw. And later we can actually just run all that code in a really single line of code, or in the case of processing, have something else that does that for us. And it's a little bit hard to go and understand what's going on right now because technically speaking, learning how to use functions the first time around feels like it's more effort than it's worth. But I give you the comparison that using functions is just like learning how to go and multiply numbers, because when you're learning 2 plus 2 plus 2 plus 2 plus 2, so much easier than learning what 2 times 5 is. You have to go and learn all these new crazy things. But when you learn about how to use multiplication, you realize it's so much better than using repeated addition over and over again. Functions really does give you a very similar value, not in terms of repetition being cut down on that, but it is a lot cleaner, more concise way of handling things. Plus, it makes your code more organized. And you don't know about me, but I love organized code. It makes me so happy, and it makes me smile in the morning when I think about organized code. Let me give you an analogy to go and help really seal the deal on why functions are so useful, because it really helps separate out the complicated stuff from the simple stuff here. So show of hands in the chat here. How many of you guys know how to drive? Okay, we got a couple drivers here. I'm assuming that you guys might have some practice getting behind the car. Either you guys have your license or you got your learners and stuff like that. Now, that's one part here. You guys know what's a gas pedal? You know where the steering wheel is. You know how to use a brake. Let me ask you another question. For those of you who know how to drive, do you guys know the anatomy of a car? Do you know how the steering shaft interacts to go and rotate the wheels by the set angle? Do you know how the gas pedal goes and increases the gas flow into the engine to fire off the pistons to do some thrust onto your vehicle? How many of you guys know that stuff inside out as well as you know how to drive a car? Not really, no. Just a little bit. You guys might, it's maybe, but not really. And here's the thing about that. I don't know either. I'm not going to lie. And it's so much more complicated behind the scenes. But the beauty of functions, much like the beauty of the gas pedal on the car, is that you don't need to know how the gas is going into the engine and firing off the pistons and turning the motor, et cetera, et cetera. You just press the gas pedal and the car goes forward. That's it. That's all you need to know. It's so much simpler and so much more beautiful for me to go and understand that. And that's all you need. Functions give us that capability because there was some engineer who built up the engine, the gas line there, the wheels, et cetera, et cetera, et cetera. But they gave you the ability, the user, to just worry about a gas pedal. Functions do the same thing. They take really, really big, complicated code here, so big, complicated stuff here, smush it into a single line so you can use it really, really quickly. And you guys actually intuitively see this in action all the time. Have you guys ever wondered, for example, ellipse? How did it draw that little circle on the screen there? Have you ever noticed that like the pixel arrangement, there's like some crazy math functions that had to go behind the scenes? How did your computer know which coordinates to go and apply, et cetera, et cetera? Probably not. You guys probably never needed to worry about that because somebody else built that code for you. Somebody else built that function for you, and you just simply had to go and use it. You just wanted a circle, boom. You just had to call ellipse. You don't have to worry about painting every single pixel on a screen here. And there's a billion other examples. Can we see that code? Technically, yes, if you do a lot of digging. Open source projects is the place where you get to learn where all that code is created. But personally, I actually have no clue how it works. It's so incredibly complicated that I can't even tell you where to start looking on that. The beautiful part is that you don't need to worry about it. If you're curious, yeah, I'd love to show you that, but it's typically very, very difficult, very, very fast. The beauty is you don't need to worry about it. You get to just simply use it. And it makes it easy for me to teach you, hey, let's just use a drawing library. You don't need to master programming. You don't need to master knowing how binary works on zeros and ones inside the computer to go and transform the words ellipse into a sequence of electrical voltages running through your computer. It's all handled for you because of functions. And so basically print, ellipse, fill, background, anytime you see like a word and those little round brackets there, that's a function that you are using. And usually you're using somebody else's function. But the really cool part is that you can actually go and create your own functions. And I'll talk about that in just a minute, because before that, I also want to go and show you another fundamental part of functions. Not only do they let you use code, they also give you stuff to work with as well. And we've seen examples of this, not as much, but there are lots of examples that are incredibly useful. And this shows up a lot more as you get into more advanced programming. For example, let's go and set up my list is equal to 3, 1, 4, 1, 5, 9, etc. And we want to say, how long is this list? Well, we have a cool way how to go and get the length of the list. That's called length, len, my list. And as a function for you. And because of, or it's not just going to go and spit out the number for us, it actually is going to go and give us a return value. That's a keyword. You ask length to go calculate the number, and then it will return a number for you, and we'll store it inside a variable. So my length is set to the length of my list, and I can go and print my length. There you go. And another function call here. Somehow it's telling the computer to pump it onto the terminal. So when I run that code, 6666666, because did I just like summon Satan or something? I should have chose that example a little more carefully. Anyway, you can go and get values from functions, and then you could feed that into other functions. And these are really fundamental concepts that when you're using functions, it comes so naturally out of the box that it's just simply trying to memorize a couple new keywords here. But the concepts you guys already intuitively know. We got another example like the random integer, randint. Those give you return values as well. And now I'm going to go and talk about the next part here. Is that we've been using other people's functions. We've been using ellipse, we've been using fill, print, etc. And now it's time for us to go and create our own functions. And actually, I'm going to go and challenge you guys right now. Can anybody tell me why in the world would we want to make our own functions? Anybody want to take a guess? Albert, you are actually correct about that. Yes, it's going to be a little unintuitive, but no one can cover all the functions for you. That's also true. That's also true. Yeah, so the reason that we use functions is basically because, well, it does shorten our code as the users of the function, and it really does also simplify it. It makes it easy to read. All those things I talked about earlier basically translate right over here as well. we create our own functions because eventually we are the engineers now. We're building really complicated things and we want to package it up and make it easy for other people to use, easy for us to use as well. Let me show you a quick example here. So see all this code here? Let me see. That's 1, 2, 3, 4, 5, 6, 7, 8. I don't know. Maybe that's about 40 lines. If I gave you the challenge to type that out in 10 seconds, how many of you guys can type out all 40 of these lines in 10 seconds? Reasonably speaking, nobody. Yeah, not even me, as much as I'm proud of my typing skills here. Nobody can type that. Nobody wants to type that either. But then you notice something about this is that what is all of this doing as well? I don't know. There's a fill that sets it to white. There's a rectangle at 40, 40, 140. I don't even know what that means. There's a triangle. Then there's fill. There's a rect. There's a rect. There's another fill, rectangle, triangle, blah, 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 blah. And you're looking at this. You're going, what in the world is all of this stuff? A, that's a lot of code on my screen. And B, I have no clue what it's doing. So now we can introduce the idea of functions. I'm too lazy to type that code out myself. But what I can go and show you guys is that let's go and take a look at specifically setup. You guys notice right here at the very top here, it says def setup. That's something you guys all know what that means here. And we see def setup. And inside it says, set the screen size here, set the background, okay. And then you see this something called draw house. Well, that's not a function that processing gives us out of the box here, but look at that. 1, 2, 3, 4, 5. And you guys can probably take an educated guess. You guys know what the name probably does here. You can guess, oh, it draws 5 houses. That's it. You can read it out like plain old fashioned English here to understand what that code is doing. And how does it draw a house? Well, then you see underneath here, this is a chunk of code that makes it happen. And it really does shorten it up and it makes it so much easier to read. So I am going to go and challenge you guys right now. Which one of these are false based on what we have shown you so far?
All right, just a few more seconds and then we'll go ahead and close the poll. All right. So we do have 78% who have answered option number C. Functions can only be called in draw.
Okay, nice job for those of you guys who answered number C. Thankfully, you all know how to understand what I'm trying to tell you rather than picking the third A on this list. Yes, functions can only be called in draw. That statement is indeed false. It can be called virtually anywhere because you saw examples of functions like print and background and size being put inside setup. You can go and use functions in draw as well. That's where we use ellipse and stuff like that. And then the other ones, let's go and show that these are true. Functions can be used as reusable chunks of code. Yes, draw house was an example of this. Functions should only be used to perform one specific action. I didn't really talk about this in high detail, but intuitively we can understand, yeah, this makes sense because this example here, I called it draw house. That's pretty straightforward, singular thing only. It's not draw house apartments and city town block and the dog and my kitchen sink while we're at it. No, it's only just called draw house. Good functions are pretty descriptive and they do one thing really well. Functions can only be used in draw. I talked about this one already. This is false. And then there's no limit on how many times you can call a function. Obviously, this part is true. We use draw house 5 times rapidly to pump out a bunch of houses. So thank you guys for answering that. let's go talk about how to actually write up our own function now. If you guys stared at the code, you would have seen it, but let's go and break it down in slower steps here. So the idea with a function is that it basically has 4 pieces in it. 2 of them are fundamentally required. The other two are optional here. So the first one, we need a name. So the name might be draw house. Then we need a body. That's the code that lives inside the function. And that's going to be like the rectangle, the triangle, stuff like that. And then we'll worry about these other 2 in a moment here. They're optional, so I don't want to focus on those quite yet. Function names. So here's another one. If we want to go and create a function called greetings, we would say def, and then you put in the name of whatever function you want. Draw house, greeting, whatever you want to put in here. Add 2 numbers together. And then we can go and plug in some text inside here. You know what? I'm going to go and code along here. Def mouse press, that's one example. I'm going to put my new function right down here. Again, line 17, you see how I got these extra spaces here? Make sure that you press delete. You want to line up all the way to the far left side here. And then I'll do def greeting. Open round bracket, close round bracket. That is my name of my function. And then I'm going to go and print hello. And that is my body. So name is greeting. Body is all the code here. Just hello. Just hello in our case, very simple. And all right, very cool. Let's go and run our code, say hello to the world. I'm going to delete this list stuff just so that we don't have to go and worry about that. And well, that's odd. Nothing's happening. Where's that hello greeting that I've just typed out? Well, the thing about this is that I'm not quite done yet because I gave you guys the beautiful way of how to go and define a function. In other words, set up a function. I never said that we're actually using it yet, though. So, oops. Here we go. Here is the name and body, just as I was showing you. And here's where we plug it in to code it, make it all happen. But it's not doing anything yet. What we need to do is the next step. This other half of it is going to be calling the function. And this is actually kind of intuitive as well. I see a lot of beginners trip up on this, but a really, really simple way of remembering this is that when you go like x is set to the value of 10, you're just defining x. You're not actually using x yet. You don't expect x to show up anywhere in your code. It's only when you do things like printing x, that's where you're using x. And we have a very similar thing when it comes to functions here. We're going to be defining the function all the way down here. It lives outside of that code block there. So yeah, the order might be a little bit confused. But now we can go and say greeting, open round bracket, close round bracket. And this is the part where we're using greeting, or more accurately, we are calling greeting. And we can go run this code. So we got x, printing x here. So that's 10. And then we got this hello section over here. I want you guys to join me on reading this over. When we are running the setup code here, it goes to greeting and it says, what is greeting? I have never seen this link before. Well, I'm going to look at where it is defined. It's down here. I'm going to jump inside this code here, run this code, which says print hello. And then I'm going to come back when I'm done and say that we're all finished with that. So it is 2 parts here. Step 1 is start on setup. Step 2 is jump inside and do the greeting. Okay, so with that, I'm going to give 10 minutes to try this out. What I want you guys to focus on right now is trying to draw circles that show up wherever you go and click your mouse. And the ideal way of doing this here is that you should be actually creating your own function called draw circle. I don't want you guys to be using just putting this directly inside of the mouse press. So what I want you guys to see here, I want to see call a function called draw circle, like that. And of course, that means you guys need to make a function called draw circle. First, start with just drawing any circle you want. Then show me that you guys mastered functions by making random colors. All right, let's take 10 minutes, try that out. All right, then. Welcome back, guys. Welcome back. I know that that exercise was a little bit rushed, but don't worry, we got plenty of opportunity to practice drawing more or getting functions more. The random part here was mostly to enforce that you guys use functions, but truth be told, there is one technical caveat. Any code that you could theoretically write with a function, you could also write without functions, but I don't recommend it. I always say that functions are generally the better idea. So it's just like how anytime that you want to use a variable, you could theoretically use in numbers, but variables are the better idea. Same deal with functions. Anyway, with that, I am going to just carry on to the next section here, and you guys will have opportunities to try practicing this even more. So the next part is something that you guys actually probably also intuitively understand as well, which is function parameters. And parameters are basically the way that you get fine-tuned control over every single function. Again, I'm going to go to my intuitive example of an ellipse. An ellipse takes 4 numbers. That's going to be the x-coordinate, the y-coordinate, it's going to take the width, and it's going to take the height, right? The computer knows how to draw the kind of oval shape on screen here. How does it know to draw the oval shape here or here or here or here? How does it know to make it this big, or how do you make it this big or this tiny? That is what parameters control. These are the ways that you can go and set things up. And if you have no parameters, oh, it's pretty darn simple to see what no parameters looks like. What we're much more interested in seeing is what parameters do look like. So no parameters right now, I already have set up like this. Greeting, open round bracket, close round bracket. That says take no optional configuration. You only get one done deal here. It says hello. But then you realize that this hello is so cold and heartless, it feels like every telemarketer's scam that at least they could put the bare minimum effort of putting your name into here, right? So let's in fact go and customize our existing function so that it can take a parameter. So just like how ellipse can control the x-coordinate, the y-coordinate, etc., we're going to go and try customizing our greeting here to go and also take in a name parameter. So name at this point here, I've been using this word parameter, but at this point onwards, inside the function body, name just acts like a variable. And that's it. Fundamentally speaking, you just have to think about name being a variable, and all you have to do is skip one part. Don't need this line. You guys get to skip this line of code because it's going to be controlled by somewhere else. If I do name is set to Richard, you do not need to worry about this line. I'll show you where you do this instead. Instead, what you do is just use the variable. So I can go hello, and then I can go and print out the name right here. So let's go and take a look at the code. We're going to have a def setup, and it's going to say set up the size here, and then we're going to have a greeting. And let's take a look. Greeting says, please pass me one parameter name called name. I'll show you really quickly. If you don't give it a name, it gets really upset. It says bad inputs because it's saying, hey, I want to go greet somebody, but you need to tell me who that is. I'm like, okay. So greetings, and I'm just going to go pump in a string, open quote, close quote, and I'll just punch in my name right here, Richard. And when I run that code, it's still getting upset with me. That's not good. Bad input on line 21. Oh boy. Let's see. Well, that's embarrassing. I got a typo in my code and I don't really see where that is. If anybody does see the typo in my code, feel free to just shout it out to me.
I think there's a space at the start of the line.
There's a space at the start of my line.
Maybe I'm imagining things.
Oh, here it is. Mouse press is broken. I'm going to just go print. There's a reason for that, and it's subtle and it's Python specific, so I'm going to skip that. But thank you for trying that out. Here we go. Now I got it working. Please ignore that. This is something that I'm going to get rid of this mouse press section because that's too distracting right now. And don't worry, it has no impact on the rest of this parameter stuff. So sorry, debugging on the fly. So what I have here is I have a greeting, and it says, okay, let's go use a greeting code. But who are you greeting? Well, I'm greeting Richard, and it's going to go and now treat the name as if it had the value of Richard. Let's go and check out. Let's see. I think my slides gives another example here. We can go into, of course, pass in any kind of value you want into these parameters. And if you want multiple parameters, all you just need is a comma. And you just start rattling them off. So how about we go and make our own calculator that goes and adds two numbers together? The way you do this is that you can create your brand new function here. You set the name to be add, and then you go and set the parameters to be A and B. In other words, you're just creating two variables called A and B, and you're asking somebody else to be responsible for telling you what those numbers are going to be. And then you sum them all up together and you just treat them like regular numbers or regular variables at this point here. And I want to just quickly walk through, hey, how does this actually translate across? Because I've seen lots of people struggle to wrap their heads around this concept. So inside my setup, or here we go, add, this is where it's defined. Setup calls the add function. And we see add is passed the values of 3 and 5 when add is called. In other words, when I use the word add, I'm going to send it the values 3 and 5 to go make things happen. Just like how in size, I send the numbers 500 and 500 to make things happen. So add takes our code and it thinks, okay, A is set to the value of 3, B is set to the value of 5. Now I can start working on it. I can do a summation of A plus B, and that's going to print out the sum of going to be 8. And so now I'm going to challenge you guys, see how well you understood what I've been typing up so far. Take a quick minute, read this over, and see if you could figure out how to go and replace these blanks here to get a proper function and parameter working. Alrighty then. Take a couple more seconds to wrap up that poll there.
All right, we have 78% who chose option number B, which I think is the
Excellent. And yes, that is the correct answer here. What are we doing here? For blank number 1, we are calling the function. Which one are we calling? Our choices are divide by 3 or literally the word function. We don't have anything literally called function on our screen here. So divide by 3 is going to be the correct answer. And we're going to send in the value 10.32. Sometimes you'll hear the word, the argument 10.32. And we're going to set that over to this parameter. This parameter was blank number 2 here. And your choices were to either set the value or set the name to be number or set the name to be result. We know that result doesn't make sense because we're trying to set result is set to the number of number divided by 3. And then I was like, oh, wait a minute, number here. There is no variable called number. So that must be the parameter in this list. So nice job, guys. We'll carry on. I want to talk about one final part here is that we have this word called return. Return is a specialized keyword, just like how def is a specialized keyword. And what it does, it feeds back the number. Remember earlier, I was giving you guys the example of the length of a list. It has to somehow give back the number, right? You have to tell it how big the list is, or when you're talking about a random integer, it has to somehow tell you which random number that is. We also are going to go and return back our own number by using the word return. It gives back the number. So let's see, I got some complicated code here. I don't feel like letting you guys or forcing you guys to read all that. So instead, I am just going to flip over to my code. And over on my code, I'm just going to get rid of greeting or, yeah, let's just get rid of greeting. Just clean this thing up. I'm going to do def 2 plus 2. Not the most creative function here. I'm going to open round bracket, and for simplicity, I'm not going to go and give you guys any parameters to deal with. So it's just going to be very boring. So I'm going to say my sum is set to the value of 2 plus 2. And I want to tell the world what is the value of 2 plus 2. I'm going to give it back. I'm going to return the sum. And with that, this greeting makes no sense anymore. I have setup, and I want to say, I want to call this code, please. And I'm going to say answer is set to the value of 2 plus 2. Open round bracket, close round bracket. And then I can go and print out my answer. And when we read that code off, no surprise, 2 plus 2 is obviously 4, but the flow for this thing, I want to show you guys. It sets, you got the setup code, it goes right here. When it sees this line, it says answer is set to the value of 2 plus 2. And run this piece of, or run this little function here, call the function, and figure out what number gives back, what it returns. So 2 plus 2 runs right here. It triggers off this code, sum is set to the value of 2 plus 2, and it returns that summation here. It returns the number 4. The number 4 is fed into my answer, and then finally the answer gets printed out. One thing I do want to highlight, because a whole lot of people I see are making this mistake as a beginner here, is that when normally you got that print answer thing, yeah, that works, but I see some people asking the question, why not just do this instead? Print sum. And I mean, yeah, technically, this would work. 2 plus 2 is set to the value of the sum here, and you can print out 4 and should do the same thing. But when you run that code here, you actually get this really weird thing, this extra word called none. Reason being, answer is set to the value of, oh, it's missing the return statement now. When you're missing the return statement, Python tries its best. It takes an educated guess what you're trying to tell it, and it gives back this very special word called none, which is kind of meaningless, because if I tried now, answer plus equals 1, just something else we've seen before, then it freaks out. It says, what the heck are you doing? I can't add none and 1 together. That makes no sense to me. So instead, printing it out, not very useful. It's much more useful to actually return the value here, return sum, just like that. And now we actually have things that we can work with up here. Answer is set to 4, and answer is actually a number that we can work with. So I could do answer plus equals 1 as a piece of code that we've seen earlier, and it now actually treats it like a number, not this nebulous none thingy. So that's a clarification I want to make, because I see so many people make that as a little typo. Anyway, another example just to show off here, it says area is set to the value of calculate square area of, here we go, pass in a parameter called 2. Well, what is this thing going to be equal to? I don't know. Let's go and take a look at the definition. Calculate square area, and you pass in a parameter called side length. Side length is set to the value of 2. Return, and then you could just put any code you want here. So you could put a variable, you could put a complicated thing, 2 times 2. Set that to the value of 4. And with that, we are good to go. Let's go and try out another exercise here. Let's take 15 minutes to try this out. What I want you guys to do now, create a function called average, and you're going to need to pass it into parameters. One parameter, call it x. Your other parameter is going to be called y. And then you got to go and calculate the mathematical average of that thing. What is the average? Well, it looks like this in terms of math context here. So you got to go and translate that into code real quick. When you call average, here comes the fun part with the fancy visualizations. Use ellipse to go and set the actual size of this thing here. Or draw an ellipse with the mouse x, mouse y, and the diameter of it, it'll be based on the average value of it. So let's try that out. Hey guys, welcome back. We are just wrapping up here on exercise number 2. How many of you guys actually finished exercise number 2? Nice, we got some people who finished it. That's awesome. Excellent, great job guys. Exercise number 2 really does, if you could figure out how to set it up, so you say, create a function that's named average, you pass in 2 parameters, and then you go and calculate the value and return it. And you actually conquered a grand majority of it. And then the rest of it, how to make those circles of pretty different sizes there, that's just simply an application of the ellipse function that we already are using. Anyway, with that, I want to just go and talk about one more thing. And honestly, in my opinion, it's so easy. The global keyword. I showed you global inside draw. That's my number one use. You can use global inside setup, and you could use global inside any of your other functions. In fact, you kind of need to, because as soon as you exit draw or setup or whatever to enter another function, you lose that global keyword and you have to kind of set it up all over again to use that. And so, for example, if you're taking a video game and your character has some health points, when they take damage, you need to go and use the word global health to go and mess around with it and do all the things you're familiar with at that point, which I think might actually come useful if you want to do complicated things here. Here are a couple other functions here that I want you guys to try building. They look wildly complicated, but we do have some hints that are built right into these speaker notes here, especially hinting on how you guys use functions. Technically speaking, you can do any of these exercises without functions, but if you do, we're not going to give you full Ignite points for that. So functions, name of the game for today's conversation here. So let's try that out. We are going to keep on going roughly until just a little bit past 7:25-ish, and then we'll be right back here. And if you're bored, more exercises to try. All right, welcome back, everybody. Thank you, guys. I believe that is end of our time, and we are just about finished as usual. So no new announcements for the end of today's class. Just to keep in mind what I announced last time is that next week, we're going to start shifting our focus so that we have a little more focus on our final projects, building up our own game from scratch using all the stuff that we have learned here. You guys can build anything you want, and I've seen some amazing things before, and I'm so excited to see what's coming up next. Other than that, though, I think that is it. We just have our regular end of session survey to ask you. And once you guys answer that, feel free to get on out of here. Enjoy the rest of your evening.